So we're separating addition and subtraction of rational expressions into two parts. This first part will be adding and subtracting when you have a common denominator already. And then we'll need to talk about creating a common denominator so that if they don't have a shared denominator, we make it so that they do. Again, all of these rules we're using really tie back to fractions and math with fractions. These are just more complicated fractions that we're dealing with here. So if we have a common denominator, or really we're just focused on this side, we're adding two rational expressions and they have the same denominator, then we add the numerators and we keep the shared denominator. Same thing with subtraction. We subtract the numerators, keep the common denominator. So, for example, if we have this case and we see we already have the same denominator, then what we're going to do is add the numerators. And this can kind of be similar to when we looked at addition of polynomials. You would take your first polynomial plus the second polynomial, and technically with addition we have these parentheses. You take that whole first polynomial plus that whole second polynomial. However, when you're adding, the signs won't change, so really the parentheses just drop. So we add our numerators and then we divide by our common denominator, which is 4x plus 1. So in the numerator I have x plus 3x, which is 4x, and then minus 1 over 4x plus 1. And now when we're at this stage, we could look to simplify our rational expression. So I would look to factor it and then look for common factors that can cancel out. Again, with the subtraction and addition here, that 4x in the numerator, excuse me, is stuck with the minus 1. And in the denominator, that 4x is stuck with a plus 1. So the only way we could cancel is if we saw an exact copy of these expressions in the numerator or in the denominator. But because these have different signs, they can't cancel at all. So this is going to be stuck just like that, even though I'm sure, even I want to cancel those 4x's, but we can't because that's stuck with a minus 1 and the denominator is stuck with a plus 1. So they have to stay just like that. All right, our expression here. So we have subtraction between the two. So again, think about polynomial subtraction. So again, first thing we need to know is that the denominators are the same. So yay, we don't need to change anything. So what we're going to do is take this first expression minus the second expression, all in the numerator. So it's like we have parentheses 2x plus 7 minus, and then these are the super important parentheses with the x plus 2. Because really that 2x plus 7, it's like there's a positive 1 out front, so those parentheses just drop. But with the x plus 2, that subtraction, or like that negative 1, needs to distribute into the parentheses. So all of that's over our shared denominator of x squared plus 2x minus 15. So in the numerator, we really have 2x plus 7 and then minus x minus 2. Over, and x squared plus 2x minus 15, I'm going to go ahead and factor that. So I need two numbers that multiply to negative 15 and add to 2. So I'm thinking that's going to be a 5 and 3. So I'm going to need a positive 5 and a negative 3. In the numerator, 2x minus x is 1x. 7 minus 2 is a positive 5. So now here, it helps in the numerator, we see this x plus 5, so those two pieces are grouped together with parentheses. And now you can see this whole x plus 5 can cancel with that x plus 5 in the numerator. So that'll leave a 1 in the numerator over, and then x minus 3 in the denominator. So with subtraction, those parentheses are going to be very important because we essentially need to distribute the negative in. Now, these were nice cases where the denominators were already the same, but if they're not the same, then we need to create a common denominator. So what we're going to do is look for the least common denominator. So in order to do this, we're going to follow these steps just for finding the least common denominator. In the next video, we'll go through actually adjusting the addition or subtraction to kind of complete the process. So just finding least common denominator, what we're going to do is completely factor each denominator. So in this process, we're really just focused on the denominator of the expressions. Once we completely factor them, we want to list each factor from each denominator and the greatest number of times that it occurs. So some of our factors might end up with an exponent on them, and where we can see possibly these different exponents, we want to grab the largest exponent. So we'll talk about that. So the least common denominator is going to be a product of those factors. So in this first example here, and if it helps, these parentheses can be helpful as a visual. So we have this whole x plus 2. So that's a factor. We have this whole x minus 2, so a different factor. And then that's it. And that would be our least common denominator, would be the multiplication of those pieces. So everything was factored already, so we didn't need to do that. And then listing out each factor, well, we have our factors coming through right there. And so our least common denominator is a product of those factors. So this one's pretty straightforward. It's just as you have these different factors, your least common denominator would end up as a string of multiplication of those different factors. Now for this case, x squared minus 4, so we could factor that to be x plus 2, x minus 2, using our difference of squares. Now over here, I see x minus 2 again, but it's not different from that x minus 2. Seeing an x minus 2 with an exponent of 1, that's already taken care of. So in making our least common denominator, we would have this factor of x plus 2. We would also have this factor of x minus 2, but I only list it once. Listing it twice would be redundant. When I would list it twice, when I would have that squared, is if x minus 2 squared showed up in one of the denominators. If I saw that in one of the denominators, then I would have it there, because that would be the idea of grabbing that greatest number of times it occurs, or that largest exponent. But in this case, is that we have this kind of shared factor, so we just use it once. All right, our next case here. So in the denominator, we can factor out a y value, which would leave us with a y minus 5. Over here, we have y minus 5 squared. And what I want to notice is that we have y minus 5, but having y minus 5 squared is a stronger factor. We need to take that one with the largest exponent. So for my least common denominator, we're going to have this factor of y that showed up times, and then we have this factor of y minus 5, and we're going to use the one with the exponent of 2 because that's largest. All right, and here let's do some factoring. So let's see, this will be an x plus 2 times x plus 2, which is x plus 2 squared. Over here, we'll have an x plus 1 times an x plus 2. So for making the least common denominator, we have this unique one of x plus 1. Then we have this factor of x plus 2 that shows up in both spots, and then we just want to grab the one with the largest exponent of 2. So with these least common denominators, we'll take it further in the next video, and with that, we'll need to keep using those, so we'll get a lot more practice with them as well.